Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Zodiac Project Sagittarius by Maze Gator. And here are the rules. Irregular Sudoku rules. Place the digits 1 through 9 once each into every row, column, and irregular region. So this is a region, this is a region, this is a region here, etc., etc. So they're denoted by the uh, what are they? Highlighted lines, bolded lines, I guess, that are on the grid. Standard arrows. Digits along an arrow, purple, must sum to the digit in the attached circle. That's interesting. So therefore, example, these two digits must sum up to what this digit is. So as an example, this could be 3 and 5, and this could be 8. Or something along the lines, this could be 3 and 3, and this could be 6. Because you can have repeats on arrows. And that's how standard arrows work. Remember that the digits along the arrow must sum up to what is in the circle. Disjoint. The 9 arrow circles consist of a complete set of the digits 1 through 9 without repeats. So every circle along the arrow has to be a different digit. And it has to contain the complete set of digits 1 through 9. So that's the disjoint sets, or disjoint rule. It's not quite the disjoint set rule set. And we finally have Renban, where digits on a pink line form a non-repeating consecutive sequence. And there's only 3 of those digits, or 3 of those lines. So say, as an example, you had a 1. Actually, let's go with 4. If this were a 4, this would have to be a 3 or 5 to make sure that this is consecutive with each other. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, this is a very interesting one here. This is 1, 2, 3, 4, 5, 6 different digits. So this is at least obviously 6. Can they all be 1 is the question, right? Oh, this is also... So this is at least 1, 2, and 3 added together. So therefore this is at least 6 through 9 also. What about the rest? Well, we know... Okay. This digit, whatever it is, let's make it green, has to be the same as that digit. This digit has to be the same as that digit. This one has to be the same as that one. And this one has to be the same as that one. And they all have to be different, though. Uh... Interesting. Well, let's see. We know one of these is a 1, right? One of them doesn't have to be a 2, though. So this could be a 1. And that could be 1, right? But if that's the case, then this is 2, 3, 4, and this would have to be 9 if this is a 1. So therefore, this would be 8 at most. The rest of these could be 1s. Okay, first of all, we know at least 3 of these are 1s. That's all we know. Where are the remaining digits is the question. Okay, so pink, aha. Where can pink be in this irregular region? It can't be here. It can't be here because it sees these, and it can't be the green because we know it's different from the green. Therefore, pink has to be here in that region. Okay. We also know where is pink in this region. It has to be one of these 4 cells. So it has to be in row 1 or 2. And what about this region? Where is the pink? It has to be, again, in rows 1 or 2, because we have it in 3, 4, and 5. Well, where's the pink then in this irregular region? It has to be one of these 2 cells. We're not sure which, though. And the pink in this irregular region is here specifically. So this one, this can't be pink, but either of these 2 could be pink. Ah. Okay, where is the pink in this region? So the pink in this region has to be one of these 2 cells. The pink in this region cannot be any of these, can't be any of these, so it must be one of these 4 cells. Therefore, where's the pink in this region? It cannot be any of these, it can't be here. It can't be here, it has to be here. Right, because this is pink, that sees there, this sees that one. This is a pink, which means that can't be pink. And then this one of these 4 has to be pink. Which means none of these can be pink. So this can't be pink, this can't be pink, this can't be pink. We don't know about this. Okay. Where is green in this region? It cannot be here, cannot be here because of these 2. It can't be here, here because of these 2, so this must be a green. Where is the green in this irregular region? It can't be any of these 3, so it has to be this one. So this is a green. So we have 1. Well, what about this region? Look, here we have that. So it's 1, 2, 3, 4. And the remaining green cannot be here in row 5, so it has to be one of these 2 cells. So none of these can be green. So one of these 3 has to be a green. This can't be green. So, okay. This is a green, which means none of these could be green. One of these 3 has to be a green, which means none of those could be green. Therefore, green has to be one of these 2 in this irregular region, so this can't be green. And since this can't be green, where is the green in row 5? Can't be any of these because we know that's a green. Can't be that because it's pink. Can't be that because we know one of these 2 has to be green. Therefore, this is the green in row 5. What about yellow? Yellow, where is the yellow in row 8? It has to be one of these 3. We're not sure which. So it's one of these 3. And then in row 9, it has to be one of these, obviously. Cannot be these 2, so it has to be one of these 5. That's too broad. Let's not do yellow yet. Orange. Can we figure out orange? Orange has to be one in this irregular region, has to be one of these 3. Therefore, in this region, where can it be? It cannot be any of the circles, so it must be one of these three. Well, what about this region? Can't be any of these, so it's one of these five. That's pretty broad. But where is the orange in one of these regions? It has to be one of these two. Because it can't be the yellow, because these are different digits. It's a disjoint set. Can't be here because of this orange. Can't be here because of this orange. So these two have to be a green-orange pair, which means this can't be orange. So one of these two is orange. Okay, so this is not helpful here. This is, well, this is fine for now. What's the most these digits can be? So we can have 1 all the way, which adds up to 6. That means we have 3 degrees of freedom left. So the 1 could go up to a 4. So this is specifically 1 through 4. Obviously, it cannot have everything go up to a 4. One of the ones has to be a green, a pink, an orange, or a yellow. That's interesting. So this could be orange, or it could be yellow. This cannot be green. It cannot be yellow. It's pink or orange. So any of these could be orange. And any of these could be orange. Yellow cannot be here. Pink cannot be here. Interesting. Okay, I think this almost guarantees that orange has to be 1. Right? Okay. What can this be? This cannot be green. It cannot be pink. So it could be orange, or it cannot be yellow either. So this has to be orange. This can't be pink or green or yellow. Oh, that's interesting. This can't be pink, green, or yellow. So this has to be a non-1. So this is at least 2, 3, or 4. Because one of these arrows has to be that goes to 1 digit. Because otherwise, this digit can't add up to a 1. So this can't be 1. This digit can't add up to 1. And this digit can't add up to 1. So one of these 4 arrows has to be a 1. Well, since this sees all 4 of those colors, this can't be a 1. Therefore, that leaves this. We lost 1 degree of freedom here. And by degree of freedom, I usually mean that basically the highest number, or whatever number to get to, can go up a certain amount, right? So 1 can go up 3 digits, and you could still maintain an actual sum with that being 9. But because we lost 1 degree of freedom here, we lose that 1 degree of freedom along that arrow. So this cannot be, none of this can be 4 now. So all of them have to be 1, 2, or 3. This can only be orange, because it can't be green, can't be pink, can't be yellow. This can only be orange, because it can't be green, can't be pink. It could be, I guess this could be yellow. So this could be yellow too. This cannot be green or pink because they're both here. So this is orange or yellow. This can't be yellow or pink or green, so this could be only orange. And this cannot be yellow, green. It could be pink or it's orange. Well, say that the 1 was an orange. If the 1 is an orange, sorry, say that the 1 is a yellow. If the 1 is a yellow, these have to be at least 2, right? So it'd be 2, 2, and 2, which adds up. And therefore, this would also be like, this could be 3 at most, at least. But the problem is, then this would be 2, 2, 2. That adds up to 6. This is 1 each. So that adds up to 8, and therefore this would be at least 11. And it's not a digit, obviously. So yellow cannot be the 1. Pink can't be the 1, similarly, because we only have 1 digit on there. So if that's a 1, the rest are 2s, and therefore that's already 9 without this digit. So therefore, orange has to be a 1. So this is a 1, which makes this a 1. The orange could be 5 of these digits, right? So, and we know 1 can't be here, so this has to specifically be 2, 3, and 4 here, which adds up to 9. Because otherwise you don't add up to a digit. So this can't be 9. We lost a degree of freedom for this arrow. So this can no longer be 4, and this can no longer be 3 here. So, these are 1 and 2. This can't be 2, because otherwise we have a 2, 3, 4 in this irregular region, and it's a triplet. So therefore, all the 2, 3, and 4s cannot be in the same region, or in all the other cells in the region. So this is a 1. This is definitely a 1, which makes this an orange. If this were a 1, this would become 2 and 2. Well, I guess any of these could be orange too. So, this could be 2. So the rest of this region is 5 through 9. So this can't be 9. So one of these is a 1. We're not sure which. If yellow... If this is orange, that would make this essentially 2 and 2. So we have 1 plus 2 plus 2. And this could be 1 and 1 still. So 1, 2, 2 is 5 plus 6, 7. Wait, 1, 5, 6, 7, which would force this to be 2. This is 2 at least. So we have 1, 2, 2. Right, if this is orange, this is not 1, so this would have to be 2. So that's 1, 2, 2. That's 5. Plus 1 plus 1 is 7, and therefore plus 2 is 9, which is not possible because the arrow circles all have a disjoint set, and we already have our 9. So this cannot be orange. Since this can't be orange, this has to be an orange, because that's the only other place orange could be for this region. Can't be here, can't be here. Can't be the circles, can't be this one, and this one was the only other one. So this is a 1. The remaining cells here are 5 through 8. So the remaining cells here have to be 2, 3, and 4. Interesting. Which means these have to be 5 through 9. Which means the purple here is a 5 through 9. This is 2, 3, and 4. This is a 2 or 3. We have a 2, 3, 4 triplet now in row 2, which eliminates 2, 3, and 4 from the rest of the row. So this is 5 through 9. This is 5 through 9. This is a 2, 3, or 4. One of these is a 5 through 9. So orange is one of these 4 for this region. Whatever this cell is not orange, and it's not this cell, so it must be equal to this one. So we're gonna make this special. We're gonna make this a blue, I guess, and this one's a red. So this has to be the corresponding blue, and it has to be 2 or 3. Well, where is the blue in column 8? Cannot be this one because we have it there. Can't be this one because we have it here. So it has to be one of these 2 cells. We're not sure. This red, so this is blue and red. We're not sure which one's which, though. Where is the corresponding blue cell in this region? It has to be here, here, or here. We're not sure. Similarly, it could be one of these 5. So that's not helpful. Hmm. This yellow could be one of the corresponding 2, 3, and 4s. Okay, so we know the blue one is not the pink, yellow, green, or orange. It has to be one of the ones which adds up to essentially another digit. So whatever this blue is has to be 1 and 1 added together or 1 and 2 added together. Right? So it has to be added from 1, 1 or 1, 2. Or sorry, 2 1s. It has to be 2 1s or a 1 and a 2. So say it was this one, right? If this is a 2, if this was a 2, this would be 1 and 1. But the problem is that would eliminate any possibilities for that being any value, period, right? So this can't be 2 if it were a 2. If this were a 2, it would have to be 1 and 1, but that's not possible. Can this ever be 2 or 3? I guess it could be 1, it could be 3, and this would be 1, and this would be 2. Or if this is 2, it would have to be with 3, and therefore this would be 2. It's possible. So this is at least 2 here, right? This is at least 2, starting from 2. This could be 1. This could actually be 1 and 1 technically, but then that eliminates all possibilities for this arrow. This can't be 6 anymore. This is 7 or 8 because it has to have a 2 at least here. Hmm. One cannot be here, but one could be any of these 3 cells. So it could be this one or this one. One could be any of these cells. And it could be any of these cells. So those are the possibilities for 1. We know one of these 2 is a 1. Oh, this one also. So it'd have to be one of these 4 cells. Oh. Okay. Well, this can't be orange because we know one of these 2 cells has to be orange. This can't be orange because of that cell, and these 2 can't be orange because of those. So one of these 4 has to be an orange, which means this can't be orange. So therefore this is green. This can't be green. This has to be an orange, and this is a 1. Where is this last... Where can the green cell be? Can't be any of these. Can't be here because that's a pink. It can't be here. This has to be a green. So this is 2, 3, or 4. Which means this has to be 3, 4, or 5, no matter what. But we don't know which one that is. This is a 1, so none of these can be the orange. This can't be 1, because if that were a 1, this would have to be 2, but that eliminates all possibilities for that cell. So this is at least 2. This could be 1. So this is at least 3. Can you ever have a 2 and a 2? So this can't be 2. This can't be 2, and this can't be 2. So therefore, one of these cells must be either the green or the yellow must be a 2. And it cannot be green. And it cannot be yellow. So this can't be 2 anymore. This has to be a 3. Right? Because either the green or the yellow is a 2. This can't be a 2. This can't be 2 because this would force this to be 1, 1, which would make that 2, 2. Which, again, this adds up to 6 already. That would be 7, 8, and this would be 9 at minimum. But we already have our 9 for the circles connected to the arrows. Therefore, this can't be 2. This can't be 2, and this can't be 2 because this can't be 1 and 1. This can't be 1 and 1. So, this blue cell cannot be a 2 because we know the green or the yellow has to be the 2. So therefore, this is a 3. The remaining digits here are all 1s because then that adds up to 8. So this is 8. So we can remove all the oranges that aren't 1. Therefore, this is not pink. This is not yellow. These are all the 1s. And this must be a 1 then. Now, this can't be 3 or 4. So this is at least 2 and 2, which adds up to at least 4. This is at least 2 and 2, which adds up to at least 4. So this has to be 3 then. This cannot be blue. where is the only possibility to be blue in an arrow circle? It has to be here. So this has to be a blue, and it has to be 3. So this is 3, which means all the greens are 2, because this is 1 plus 2. The remaining, this one has to be 4. So this can't be 2 here. Where's the last remaining 2s? 2 cannot be here, 2 cannot be here. So 2 is one of these 2 cells. In addition, 2 has to be one of those 2 cells. So this can't be 2 either. This is at least a 4. So this is at least 4. This cannot be 4 then. This is at least 6. It could be 6 or 7. This is at least 4, so this has to be... This is 4 or 5. So this has to be 2 or 3 at most. Because it cannot add up to 8 anymore. So it'd be 3, and this has to be at least 4. It could be 2 or 3 with 4 or 5. This is at least 4 here, and it has to be 4, 5, 6, 7. This can't be 8 or 9. So this is 5, 6, or 7. We don't know what the yellow is. The yellow cannot be 1, 2, or 3. This is 2 through 5. It can't be 2 here. So this can't be 2. So this has to be 6 or 7 also. And it has to be 3 or 4 specifically. Because there's no 2's available here. So this has to be 3 or 4 at least. So this is 6 or 7, this is 6 or 7, which forces this to be 5. So this is 5, this is 5. What's the last remaining one? It must be 4. So these are 4 then each. This can't be 5. This can't be 5. This has to be a 5 because it's a pink. This is a 5. None of these can be 5s. One of these 2 is a 5 because one of these 2 has to be a pink. So this can't be 5 anymore. This can't be 5. This can't be 4, so this must be a 3. Which makes this a 4, which makes that a 3. So this 3 is the blue. This is obviously not blue. The red is essentially the yellows. So these are all yellows. This can't be 5. Cannot be 5. This is 6 or 7. It's 3 or 4 with it. This can't be 3, so this must be 4, which forces this to be 7. So this has to be 6 then, which makes this 2 and 4 specifically. Neither of these can be 2 because of the irregular Sudoku rules, so this must be the last 2. So these are all green. The 4s are all yellow. This can no longer be 5. This can no longer be 5. Okay, so this can't be 6 here. This can't be 7. This can't be 7. These can't be 6. Where's the last yellow? What about column 4? Where can the yellow be? We're actually in this region. Where's the 4? Can't be here, can't be here. Can't be here, so it must be one of these 2. We're not sure which. So one of those is a 4. Where is the 4 in column 5? Can't be any of these. Can't be here, so this must be the yellow. And therefore, in this region, the yellow is one of these two. So this has to be a 4. Where is the 3 in column 5? It cannot be here, so it must be here then. So this is the blue, and it's 3. This can't be 3. So one of these two is a 3 in this region, because this can't be a 3 because this is 3, which means one of these two must be a 3. So one of these is blue. Therefore, this can't be blue. We know this is blue. Or this can't be blue because of this blue. So therefore, one of these two regions has to be 3. But if this were 3, it has to be next to a 2 or 4, and it can't be either one of those there. So this can't be 3. Therefore, this is a blue, which means this can't be blue, which means this is a blue, which means this can't be blue. And I think we have all the 3s now, right? So these are all 3s. Yellow's one of these two. Yellow's one of these two. We have all the 2s also, and we have all the 1s. The 4s, we've kind of limited it. 5s, it's a lot. This can't be 8. So the rest of these are 5 through 9. This can't be 5, so it's a 6 through 9. This is 6 through 9. This is 5 through 9. These are consecutive. 5 through 9, but this can't be 5. 5 through 9, 5 through 9. This is just 5, 7, and 9 left. Which means it has to be next to 6 or 8. This is 6 through 9. In this region is 4, 6, 8, 9. But 4 cannot be here. This is 6, 7, 8, 9. And this can't be 8. So one of these is an 8. So since this can't be 5. One of these is an 8, so it has to be with 7 or 9. Which means this is 6, and then one of them has to be 7 or 9. This can't be 6. This can't be 6. These can't be 8. These can't be 9. So one of these two is a 9, and they both... Okay, this can't be 7. This can't be 7. Oh, that's interesting. This can't be 7, and this can't be 7. Well, where is a 7 in this region? It can only be here. So this is a 7, which means this has to be 9. This has to be 5 then, which makes that a 6. This can no longer be 5, so it's not pink, which means this is the only pink left, so this is a 5, which means this can't be 5, so therefore this is a 5. This can't be 5 or 9, so this is 7. This can't be 6. This can't be 9, so this is a 6. Which means this can't be 6. This is 4 or 8. This is 4, 8, or 9 then. This can't be 7, and neither can these. Where is the 5 in row 8? It has to be one of these two cells. So therefore, this cannot be a 5. But this can't be a 5 either. So where's the 5 remaining in column 9? It has to be here. So this is a 5. This is now 6 or 9, which means it must be with 7 or 8 to be on the Ren band, to be consecutive. Let's see. Whatever this digit is has to be the same as that digit. So this is 6 or 9, and this can't be 7 either. This can't be 6, this can't be 6, so this is 8 or 9. So whatever this digit is has to be the same as this one, which means it's either here or here. We're not sure which. This one can't be here, so it has to be one of these two. We're going to make this dark, I guess. So the corresponding one has to be one of these three. It cannot be any of these, so it has to be actually the same as this. So therefore, this is a 7, 6, or 9 also. So we have a 6, 9, 6, 9 pair in column 9. So the rest of the column cannot be 6 or 9. Therefore, this is 7, 8, 7, 8. We have a 7, 8, 9 triplet now in row 6, which eliminates 7, 8, and 9 from the rest of the row. So, and it can't be 6 here, so this must be a 5. This can't be 5 or 9, because that's what's left. So this is 7, 8. This is a 7, 8. This can't be a 9 because of the 8, 9, 8, 9 pair in row 5, which eliminates 8 and 9. So this must be a 6, which makes this a 6. This has to be a 7. All the darks are 9s then. This has to be a 7. This has to be 7 specifically because this can't be 7. Therefore, this must be the 8, and that must be 7, which makes that an 8. This can no longer be 8 because of the region. This can't be 8 because of the region. This can't be 6 because of the region. So this is 4, 7, or 9. This can no longer be 8. So it's a 7, 9, 7, 9 pair for this region, which eliminates 7, 9 for the rest of the region, which makes this an 8. This can't be 7 or 8, so this must be 6, which makes this a 9. This can't be 6 or 8, so this is 7, which means this can't be 7. So we have a 4, 9, 4, 9 pair in this region, which eliminates 4 and 9 from the rest of the region. Therefore, this is 7. This can't be 7 or 9. This can't be 6 or 7, so this is 8, which makes this a 6, so this is not the red. This can't be 6, 7, or 9, so this makes that 8, which makes that a 4. That makes that 9, which makes that 4. This is obviously not the yellow. This is not yellow. So this is not 4 or 8. It has to be 6. This can't be 9, so this has to be 7, which makes that a 9. These can't be both. These both cannot be 9. This can't be a 9. And this can't be 6 because of that 6. Therefore, this is an 8, which makes that a 9. This can't be 8 or 9, so this is 6. This can't be 7, so this is 8, which makes that a 7. This can't be 8 because of that 8, so this is a 9. And therefore, this must be an 8. And that's the solution. Pretty straightforward, actually. For this such a long arrow, right? Basically, it requires you to sort of logic out where the ones can be, and then basically figure out how many ones can be on here and which one does it have to be. Because this one essentially broke open this part, which made this 2, 3, 4, and 9, which meant this couldn't be 9. And also this part, figuring out where all the ones had to be, or where all the 2s and 3s could be, right? You figured out that the 2s could never be in any of these, or sorry, the 2 cannot be in any of the arrows which have more than one digit. So therefore, it has to be one of these. Therefore, you lost all degrees of freedom here, which meant this had to be a 3, and the remaining ones had to be a 1. And then it basically was straightforward from there. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.